Ladies and gents, welcome to my first attempt here to get Screencastify to capture a lesson for us. So we'll start with this lesson that was barely just given in class called What is Science? And this video will cover not only some effective note-taking techniques, but it'll basically give you all the tools you need so that when there's an assessment coming up, that you'll be able to ace it and really understand the basics of what is science, the most important part of understanding the purpose and meaning of science as an enterprise. Okay, so as you can see on your screen, we've got Introduction to Jobs in Science, where I'll ask you in a moment to think about jobs in science that you can just come up with. I'm sure there are many you can think of. So have that in the back of your mind. Then we'll go on to Cornell notes, and I'll show you a better approach, how I use a really cool system to make Cornell notes easy to understand, excellent when you take them down, and it's clear to you what's the most important information as you take your Cornell notes during any lesson from now till the end of the year. Okay. We're going to go over today's topic, fact, theory, hypothesis, and belief, and then we'll wrap it up with a few words on the scientific method, the system that science uses as we study the natural world. Okay, we're going to go ahead and get started. If you would like, at this point, go and grab a piece of paper. Notebook paper is fine. Or if you have Cornell notes of your own already printed, feel free to grab those and have them ready for that part of our lesson today. If you need to pause it at any time, obviously you have the freedom to do so. All right, here we go. Oh, let me take my little image here, and there we go. Now we can see the whole screen. Let's think about jobs that use science. I would give you a whole minute, but you're free to pause it if you want to think about it for a second. Come up with a couple different jobs in your mind as to they may not be exactly scientist jobs, but they use science. So take a look at in your imagination. Take a look and see if you can come up with a few jobs. Try and come up with 3. That would be a cool number to come up with. So I'm going to think for a second. Get my 3 jobs. Okay, I've got 1, 2. Okay, all right. I've got a couple jobs in my mind, and I'm going to jump forward to the next slide, and we're going to take a look at some of those jobs. So keep your 3 that you've thought of. Take a moment, hold them in your mind. All right, let's take a look at some examples of jobs in the real world, important jobs that use science. All right. What is science? Science is all the things these people in these pictures do. Take a look at the man on the left side of your screen, looking at the films there. That's a doctor, not an actor, but the real doctor who works in a neural surgery ward in Mexico City. And he, like Doctor Strange, right, from Marvel Universe, he repairs people's spinal column so they can walk. He repairs damage to their back so that they don't lose nerve endings or become paralyzed. That's a critically important job in science. Take a look at the lady in the middle of the screen. We could say, oh, she's a weather girl or someone who studies and forecasts what's going to happen with the atmosphere. Can you think of the job title that she has? Not weather girl, that's diminutive. We got a better word for that. Can you think of it? If you came up with meteorologist, well done. That is her job title, meteorologist. So she's doing great. Look at the bottom center of your screen. You've got this lady, a scientist in the lab, who's mixing chemicals and tweaking formulas to try to maybe cure something. Maybe she's curing a disease. Maybe she's working on new headache medicine or something along those lines. Absolutely critical to do science correctly for people like this. Look on the top right now. You may think, oh, he's standing next to something that is seriously, burning. It's on fire. What is it, a forest fire or something? As it turns out, and some of you will be like, no, that's not a forest fire. Clearly, that is a lava flow coming down from a volcano. Volcanologists, a very important job in science, in predicting volcanoes, when they're going to erupt. Are they going to keep erupting? Are they done yet? Should we evacuate? Should we stay put? Where's the danger zone? That's a really important job for places that are active volcano zones. Underneath the volcanologist, take a look at the scientist looking through the microscope. I want you to imagine for a moment, think of what she could be looking at. Could it be microorganisms, right? In today's, modern world, she could be looking at viruses, trying to consider which virus is the threat right now. How do we kill it? What's a vaccine or an antidote? Anything like that that will help manage and save and make people's lives better in the face of threats. Or she could be looking at something completely different. What if she's looking at a mineral sample? What if she's analyzing a piece of rock that came back from the moon? Speaking of the moon, look on the bottom there. Okay, so she could be looking at a sample of a mineral to see, was there ever water on the moon? Or maybe it's a piece of rock from deep in the earth or the bottom of the ocean, and we're trying to understand the chemistry of where life is, where life began, or the history of the earth written in its rock layers. Very interesting work. And seeing the small, tiny world, the microscopic world, is very revealing in science. Take a look at the gentleman on the bottom right. That's an astronaut, and obviously you know this, but where is he? Surface of the moon. Sure enough, that is one of the Apollo missions where we put people on the moon and brought them safely home for the first time. Magnificent achievement. If that astronaut and all future astronauts don't pay close attention to the science, what could happen to them? Yeah, things could go horribly wrong if they don't follow their procedures perfectly. Or if he forgets to seal his glove or his faceplate exactly just right, that could be really bad for for the mission, for his personal safety, or whatever. Everything could go sideways very quickly because there are places, scientists and those who work with science, places they go that are very unforgiving when it comes to people who don't take it very seriously. All these jobs, what did you think of before? Was it some of these jobs maybe that you thought of a moment ago? I bet you came up with some pretty good ones. All right. With that in mind, let's get into the next part of our lesson today, where you're going to be taking a few notes down. So let's consider note taking and how we can explore what is science and capture the most important pieces in your Cornell notes. Okay. So let me encourage you right now, if you already have printed versions of Cornell notes, go ahead and grab those, have them handy. If you want to come by the school and pick some up, I have piles of these Cornell notes to give you. Swing by, pick them up. But Mr. Sandrock, I don't have pre-printed notes. Am I out of luck here? In a moment, I'll show you how you can create your own from an ordinary piece of notebook paper. Many of you have already done this before, so feel free to skip a little ahead if you've already got Cornell notes and you understand how important and helpful they are, or you've got your own and you're ready to go. Feel free to skip forward a little bit in the video, a minute or two. Okay, so let's take a look at Cornell notes. All right. This is a pre-printed version that I found on the internet. I printed on tan paper for my students in class, just because it distinguishes it from other papers in people's folders and such. What's the purpose? What's the big idea? That, obviously, the top section, section number 1, captures not only what's the topic, but also your essential question. I like to think of the EQ as, why should I care? What's the point? Why should I invest myself, my time, in taking these notes? How do they better me as a person or my understanding of the topic? The essential question. In this case, what is science is a good one, and I've got another EQ for you to consider in a moment when we begin the part of this lesson. So at the top, if you haven't already, go ahead and fill out the top of your paper. Name, you know the class or it's science, period, whatever period you're assigned to, that's up to you. Today's date, topic, what is science? The EQ we'll get to in just a moment. The notes section, question section, summary section. These are all important. They specifically block off parts of these notes because they want you to be able to use them in a way that makes your mind mighty, makes your mind strong. Not just, I memorized a few facts because I saw them one time. No, like strengthen your mind. It's like giving your muscles a workout, a little bit at a time, and eventually you have great strength with you. Or going out and getting a walk, you have fitness. This is giving your mind a little workout of its own. Okay, so number 2 is where we'll spend a chunk of today. Number 3 and number 4, the very end of this lesson, I'm going to encourage you to write down a question or two and put a summary sentence down there because that re-strengthens what's in your mind, what you've learned, and locks it in place and helps your understanding. All right, well, Sandrock, what about if I don't have printed Cornell notes of my own? Am I out of luck? Well, take a look. Let's create your own from a piece of paper. Here's an example I've drawn up. You can make yours look as you see fit. Tweak it and find a style that fits your best preference. At the top, your name, your class, the date. Right across the top line, essential question. Inside the notes, I would put the topic, and then you have a space to fit the notes. So a bold line right across that top line, and then down the side of the paper, you can separate however much space you want to give yourself a place to write questions and a summary at the bottom, and boom, now you've got Cornell notes. Boom, you've got it. You're ready to go. Okay, pause it here if you want to make sure that everything is fine before we move forward. With your notes ready to go, I put an icon, this little green hand, square with a hand holding the pencil. That is your cue. That's your got it. There's something on this slide I need to write down. If this picture is not there, sit back and watch a little bit. Okay, kind of just listen in, and you'll get the basic ideas. But if you see this picture, look for the words in green, my friends. The green words get you to a B level of understanding. It's written that way. You can't just write down notes and say, I'm going to get an A in this class forever. It's not that straightforward and easy. You have to put a little bit of work into it yourself. That's where you take the B level, raise it to an A level by adding a little bit of your own. Some people like to do little stick figures or circles, or they draw arrows, or they underline, circle, boldface, highlight. Find what works for you when you take your notes. Emphasize things, connect ideas together, put down examples. That's where you have your control over your notes, and take it from a B level, the green words on the slides, and add a little bit to it of your own and push it up to an A level of understanding. That's the goal. That's the overall strength of Cornell notes and how we do them in this class. Okay, moving forward, let's go ahead and begin. Here we go. Ready to take notes? Got your Cornell notes ready, pencils out. Here we go. Everything from now forward is testable. Okay, you're going to see it on quizzes or activity worksheets or eventually even a test, a pretty solid test. Sometimes you'll be creating a project of some sort, maybe a sketch of some kind with explanations. There's lots of visual things we're going to be doing in class to spice it up and make it interesting. But from now forward, everything you're responsible for. The green terms, watch for those. Here we go. So we've got the icon on the screen down there below. You see that down there, and we've got some green words on the screen. Top of your page, essential question. Here you go. There it is. What makes science different? Different from everything else people do, different from religion, different from politics, different from other professional jobs. Science has a plan, it has a system, it is all these things. So write down your EQ, pause it if you need to. I'm going to keep going. Now, before you start rushing into writing down all those words, take a look at what's underlined, and I've put it in green further down below. So the words in green, capture those. Science should be the first word underneath your topic, okay, in your Cornell notes, in your notes section 2. Systematic, just write the word, leave a space. Testable, leave a space. Explains, leave a space. Predicts, leave a space. Now, instead of writing a whole sentence that is a little bit wordy and a little bit maybe confusing, you've captured the basic, most important ideas. That's the purpose of the green words. Let's get rid of the confusion and make it clear. What does the teacher think is important? There we go. Now you know what I think is the most important thing. Capture it for your notes. Systematic, testable, explains, predicts. Here's how you can take this B level of note taking and push it up. Take a look at the word systematic. Okay. What's the root word of systematic? You said system, you're correct. Look in your notes where you wrote down systematic. Underline the word system, please. Underline the root word. Because now you've taken a big long definition, right? And you've connected that science has a system. And we'll talk about that later. Now it's a very solid idea rather than some confusing definition. Science has a system. You can test ideas. How do we test ideas? I bet you've had a science lab before. So next to testable, I would put the word experiment or lab. Sorry, there's an announcement on the intercom. So science is testable. Okay? We test our ideas with experiments. Okay? And science explains things. I don't think we need to explain the word explain. You can just leave that blank for now. And then predicts. Science makes predictions. Some of you already know what a hypothesis is. Next to prediction, I'd put the word hypothesis or predicts an outcome. Okay? So somehow add a word or two of your own understanding after words like this, and that makes them better in your own understanding. All right. Moving forward, pause again anytime you need to write things down. If I'm moving too quickly, make me wait. All right, next slide. All right. Now, look on this slide. I didn't put the little icon and there's no words in green. So in this one, just kind of rest, relax, and take a look at it. All right, so science is systematic. Your job ideas that you came up with, jobs that use science, and the ones that I put on the screen, here's a couple of them. No matter what the job is, science has to be adhered to. The system has to be followed. There's a systematic approach. Science with its system makes sure it is done right. That's really important for people to trust science. If someone goes off and makes up their own rules as they go along, if they commit crimes or if they're doing deceitful things or they're in it for the money, quickly we lose respect for people who do things like that. So the system is designed to make sure science is legit and trusted. That's important. All right, next slide. Here we go. This is the common system. More green words. I see the icon right there below the picture here. Okay, cool. So now go ahead and grab the green. The common system is what? Fact, hypothesis, theory, and yes, in science, there are laws, laws of nature. We'll get to that in a second. Now, you could write down fact, observations, or experimental evidence verified by repeatable measurement. How about this? Fact equals evidence. Cool. Got it. Facts equals evidence. So evidence, mainly facts, are things that are not in dispute. For example, I'm going to grab this baseball right here. Keep a baseball at my desk and pretend it's the moon sometimes. Now, observe gravity. Okay, gravity pulled it down. I'm going to test it again. All right, gravity, 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 gravity. Gravity pulls downward. That's a fact. I could do this all day long, and it would never be any different. Fact, not in dispute. Gravity's real. I can prove it over and over and over again. No big deal. That's easy. Okay, so a fact is not in dispute. Fact equals evidence. Next, hypothesis, an educated guess. Every time I say to you in the videos or here in the classroom, what is a hypothesis, my friends? I'm going to expect educated guess. every single time. In future lessons, you're going to hear me say, all right, so-and-so made an educated guess, so they wrote what? And I want you to come up with hypothesis. Got it. Theory. This is an idea that other scientists have challenged, and it has never been proven wrong. It has stood the test of time. It's legit and it's correct. It's correct because really smart, dedicated people have tried to disprove it, and you can't disprove it. Lots of theories out there. Theory of evolution is a good one that has been proven over and over and over again to be correct. The Big Bang Theory, right? Not the TV show, like the real thing about the beginning of the universe. Big Bang Theory. It's correct. It's not just somebody's half-baked idea. It's a real thing. It's legit. It's correct. It has been proven over and over again. So scientific theory, it passed the test. It's real. Law of the universe describes something that is common everywhere. We looked at gravity. Gravity pulls down. That's a fact. We know that everywhere in the universe that we could possibly imagine, this law holds true. This fact of gravity pulling down towards the center of mass holds true. And if it is true everywhere we are, then it's a law of nature, a scientific law, the law of gravity, common aspect everywhere in the universe. Make sure you've got your green words before we move on, and let's go ahead and move forward. Here's some examples of what we talked about. Fact. The outline of Africa and South America look like they fit together, like pieces of a puzzle. Okay? Anybody can look at a map and go, yeah, I see how Africa and South America can fit together like that and perfectly match. Pretty close. The educated guess as to why that is came from a guy named Wegener, who in the 1930s studied this and said, well, if they fit together, but they're not together now, then a long time ago they were probably together and they've just been moving apart ever since. So he came up with an educated guess, a hypothesis of continental drift. So the continents are moving, and the other scientists laughed. They thought that was the most ridiculous, stupid thing they'd ever heard. They said, are you crazy, man? Continents drifting? What, whole mountains are just floating on the water? And he said, of course not. He couldn't prove it, so it was just an educated guess. He knew it in his heart, but he had no facts to back it up. It had not yet stood the test of time. But the idea was in the air, wasn't it? So, eventually, his idea of continental drift, other scientists studied it, the Navy researched it, looked at the bottom of the ocean for a lot of different reasons, but the more facts accumulated, the more proof developed together to create our theory of plate tectonics. It is now an idea in our modern day and age. It has stood the test of time. Other scientists have tried to prove it wrong and say, nah, the continents have always been standing still. They can't prove it wrong. It has stood the test of time. It is a fact. It is real. It is a theory that is a scientific correct. Okay. All right. Moving forward. So let's see if you're understanding this. This is an activity that checks your understanding. Are you with me? So beliefs, we're not going to really go into much in this class. Okay. Beliefs are for a matter of personal faith or a matter of like what you feel is true but not scientifically factually proven. But we have to consider something can say, I know this, but it's their belief. Whereas we can say the facts are this. We need to be able to distinguish those two. So I've added the word belief to this. In the moment that follows, I'm going to show you some statements one by one, and you have to decide, is it a fact or is it a hypothesis or a scientific theory or is it someone's belief? Okay, so we'll go through these one by one. Ready for this? You got to decide which one it is, and see if you were right. Here we go. Let's do this. All right, we're going to read it. I will discuss it a little bit. You decide as we go. First statement is volcanoes erupt because the gods are angry. Fact, hypothesis, theory, or belief? Fact, hypothesis, theory, or belief. I bet you know what it is, and I'm going to show you the answer now. Make a choice. Belief. And there was a whole city of people who lost their lives basically because they believed the gods were in charge and they didn't evacuate when they had the chance. So yeah, this beliefs can be very strong in humanity. So there we go. Definitely number one, belief. Number two, gravity always pulls down to the center of mass. Now, you know the law of gravity. We've talked about the law of gravity, but I didn't give you that as one of the choices. Take a look at the statement. Gravity always pulls down to the center of mass. In this case, gravity pulls us toward the center of the earth. Is that a fact, a hypothesis, theory, or belief? Make a choice. It is a fact. Definitely fact. Okay. That's not in dispute. Anybody anywhere on the earth, gravity pulls down toward the center of the mass of the earth. That's a fact, easily verified anywhere we go. All right. How are you doing so far? With me? 3 more to go. Have you gotten them all right so far? Let's see how you do on the others. Number 3. If I drop a stone, then it falls faster than a feather. Before you automatically answer, oh, I know what it is. Glance back at your notes for a second. See if there's a clue in the sentence in front of you that you took down in your notes. If I drop a stone, then it falls faster than a feather. Take a guess which one you think it is, and I will tell you the answer. This one is, since it is worded if and then, hypothesis. If you said fact, maybe that's a fact for you right there in your room or wherever you're watching this, library or the Wi-Fi at a McDonald's, right? Wherever you're watching this, that may be true where you are. But I can think of lots of places where a rock, a stone, and a feather don't fall separately from each other, but they fall together. When the astronauts went to the moon, I think it was Apollo 15 or 16, they took a rock, they took a feather with them. One of them climbed down the ladder and he had the camera and he's like, all right, I'm ready. And he held them up and let them go and they went boom, perfectly together. There was no air slowing down the feather, just straight down together. So look at the way it's worded. I try to put clues and indicators into my tests and quizzes and knowledge checks for you. If then. I'm setting a condition and I'm making an educated guess about what will happen. If then. Okay? So that is a hypothesis. Look for the wording and you'll get it right. Next. Universe began with a big bang. Cool. All right. So Big Bang is what? I bet you got this one and you don't even need to pause. Big Bang Theory. Yes, indeed. The Big Bang is a scientific theory. It's been proven correct over and over and over again, has 4 strong lines of evidence proving that it's correct. The details of it are in debate, but we know there was a beginning of the universe that was impossibly small and unimaginably dense and hot, and boom, everything in the universe now sprang from that point. That's the Big Bang. All right, number 5. Our freshman class is freaking awesome. You really have a choice to be awesome or to not be awesome in today's day and age under these conditions. Pandemic rules apply, right? What do you think? Is this even a debate? I think this is a fact, not in debate. Fact. You guys are awesome because anymore, you have to be. You have no choice. Many of you are learning and watching this video from home, right? Talk about a weird way to do school, but you're doing it. You're here. You made it into the video. You're making your way through this. You are, and you have to be freaking awesome. You really have no choice anymore but to be amazing. And that's who you are. Okay, don't lose sight of that. Okay, how'd you do overall? 5 for 5, I hope. Okay, watch for those clues. We'll review this stuff more as we go forward. Moving on. Well done with that activity. Thank you for participating. Okay, there is a video. I'm going to link it in Canvas, in modules. I'll also try to link it in YouTube if you're watching this through my YouTube channel. So look for the link, and I want you to consider what natural science is and take down some fun words from that, add those to your notes. Okay, so that's a separate activity. You can catch up with that one later. So if you would, right now, write natural science is for the next line in your notes, and you'll fill it in when you watch that video. It's like a 1.5, 2-minute video. It's pretty cool, pretty short. Natural science is. Okay? All right, look for the link. Do that one after this one's finished. Okay, now, science ideas are testable. We need a system. Okay? Now, I think this is our last taking notes slide. So go ahead and make it good. Make it a good one. The scientific method is a really important aspect of science being legit and trusted because it's a standard system everywhere you go. It's the same no matter what. We start by asking a question. My friends, science starts with a question. Questions like, can I make a better pain medication for people who are suffering? Can we get people safely to Mars and start building a colony or a city on Mars, right? Can we find ways of improving our intelligence and our awareness so we can stop messing up the earth, climate change and pollution and all that? Can we save the planet from ourselves? Those are all valid, really important questions, okay? And all science starts with a question. Then we're like, how can I do this? What I'm going to do is, all right, if I'm trying to make a better pain medication, what I'm going to do then is take the pain medication that already exists. That's my starting point. And I'm going to try to make it stronger or better, more effective, make it last longer, right? So if I could take Advil and instead of it lasting 8 hours, if I could take Advil and make it last 30 days, so someone isn't in pain for 30 days, cool, right? So I'm going to do that. I'm going to predict what will happen. My prediction, an educated guess. What's an educated guess, my friends? Say the word. Say the word. What's an educated guess? Hypothesis, right? An educated guess is a hypothesis. If I make a better pain medication, then it will last much longer. If we properly build a rocket ship with everything in it humans need, then we can survive the harsh environment of the surface of Mars or the surface of the moon. If then, I'm making an educated guess and I'm predicting what will happen. And then we make it happen. Then we do the experiment. I'm going to go into the lab and start mixing formulas to make a better pain medication. And then I'm going to see if it works. I'm going to test it on whatever my process is for seeing if it works. Watch carefully. Did that work? How's that going? How are you feeling, person who's volunteered to help me with this study? Did it work? Write down the results. Very carefully observe. Write down what actually is shown to you by your experiment. You can never just make stuff up to say, ha, see, I was right. I was right. It worked. You cannot make stuff up. Science is only legit if the scientists and the people who do it are honest with the results of the actual study. That's so important. And then in the end, you get to publish your results and share them with the world, get paid, let other scientists test your ideas. And they're like, yep, that scientist over there did it right. I agree. This pain med will work. Or other people will be like, wow, how SpaceX went to Mars, that works. I'm going to do the same thing. And I'm going to make my company, Virgin Galactic, or whatever other space company, I'm going to go to Mars too. So sharing with the world, very important as a final step in the scientific method. So hopefully you've got your green words written down. Add a little bit to anything that isn't clear to you. So for instance, suggest what might happen. If you want to add the words, what might happen. Or to your notes, predict, educated guess, write the word hypothesis. Boom, there you go. Now you're connecting big ideas in your mind, making it stronger. So look over all of these, add any words you wish before we move on. So, Cornell notes are almost complete. We're finished with part 2 of the notes. You still have that side down the side of your paper for questions. Add those questions now. Please come up with 1 or 2 questions. Let me give you an example. We asked initially, what is science? How about this question for that sidebar for questions? What are the most important parts of science? Or how do scientists know they're doing it right? Or what is the system scientists have to follow? Come up with a question of your own. You can use my questions or come up with questions of your own. Please do that. Pause me now. Write 1, 2 questions, okay, to which your notes give the answer. Pause me now and write those things. And when you're done with your questions, take a look at the bottom section, your summary. Here's what I would suggest for your summary. If someone missed class, like they didn't see the video yet, or they didn't make it that day we talked about what is science, and they're like, yo, I missed science class, what's it all about? Your summary would tell them, today in class we learned the most important parts of science, including fact and hypothesis and theory, and what those mean. We learned that science has a system called the scientific method. Boom. 2 sentences later, you've captured everything we talked about today. Or it could be something like, a lot of jobs in science have to follow the system or they're doing it wrong. Or science is legit because the system is in place and it is trusted and consistent no matter where we do it. Any of those sentences, write your own, okay? And we're going to wrap up our lesson here right now. Wherever you are in your modules in Canvas, move on to the next one. When you're done here, there will be more information following. Thank you for tuning in, my friends. We are now complete with our class. All right. I'm glad you're here. I'm glad you tuned in. Please email me at the connection through Canvas. Send me a message, and I'll get back to you as soon as I can with your answers. All right. Well done.